our airport site. All right, so today we're going to do another aspect of the hydrology labs. And I want to give a poll actually for everybody. How many people read the whole write-up before lab today? Oh, 2. Yikes. Okay, so I really want to emphasize that that's an important thing to do, and that it's an unreasonable expectation that you will do the best you can on a lab report if you haven't read the lab manual before you come out here. Okay? I would not expect myself to do well on a lab if I didn't read it beforehand. So take the 15 minutes that it takes. You can even do it on the bus and read through it so you have a clue of what's going on when we come out here. And then you can start thinking about the discussion questions. And that's maybe the best thing you could read. If you're not going to read anything else, read the questions that you're going to have to answer. Then you can be thinking about it. You're already working on the lab report. Does that make sense to everybody? I want to emphasize too, the labs are worth 50 points each, and so 2 labs is like an exam. It's worth an exam. So the lab is a great place. If you're not happy with how you're doing on the exams, this is a great place to make up for that. But that only makes up for it if you do well on that. So you want to give yourself the biggest fighting chance that you can. Okay? Cool. All right. Sorry I had to bring that up, but just we all want to see you guys do well on these, and those are the basic things that help. Okay, so we're gonna repeat some of the concepts. So that's another thing that's disadvantageous about all these labs. We repeat concepts over and over again, and we're gonna repeat this concept of topography and this difference in aspect. And also we're going to start considering soil formation processes that we've been talking about in lecture. So we talked a little bit last week about this hollow and how the soil might be different and how soil formation processes might be a little bit different at these different points in this hollow. So the north aspect being a little more moist, and we found that overall last week. You guys remember that? You found that you had higher soil moisture content in the north, and that the highest was in the hollow, right? And the lowest was the south. So where should soil formation processes be happening more rapidly? In the hollow, yeah. And then the north would still be higher than the south, right? Cool. Okay, and so we talked about the hollow, and we call it a hollow. It is this convexity in terrain, and that's the water is moving through this landscape towards that low point and then out. And with the water, it's also bringing the smaller soil particles. It's bringing nutrients. It's bringing all these cations towards that lower part of the terrain. And so just from that process alone, we would expect the soil textures to be slightly different in the hollow than on the slopes. You guys remember that discussion that Kelsey talked about last week? Okay, so what do you remember from that? Can you tell me where would we expect more fine soil particles?
The hollow?
Yeah, in the hollow. Why? I just explained it. Why? Somebody tell me that.
More weathering.
There is more weathering, but the other reason.
Particles get carried down with the water.
Yeah, the particles get carried down. So overall, we have fine textured soils all over this site, but this effect is going to be enhanced by these differences in topography. Okay, why might we have overall fine textured soil in this site in the valley? Yeah, this soil here is glacial lake Missoula sediment. So it's very fine textured lake sediment that's settled over time. And that's the parent material that we see here. Okay? Cool. So today we're going to get our infiltrometers and we're going to measure infiltration rates, and we're going to use some Excel tools that Kelsey will provide on Moodle to calculate the hydraulic conductivity as well. So, who can tell me what infiltration rate is? Yeah, it's the rate at which water enters the soil. It's a pretty simple concept. But what is it? What influences infiltration rate? Okay, cool. Yeah, which are an aspect of hydraulic conductivity, right? The hydraulic conductivity of a soil is influenced by the matrix potential and also the gravitational potential, right? Okay, great. So you might expect that fine textured soils would have more adhesion or less adhesion? More. Yeah, right? But there's something else too. The movement of water through fine textured soils is that generally can water flow through fine textured soils at the same rate as water flows through coarse textured soils? No. Coarse textured soils it can flow a lot faster. So they drain a lot quicker. So if you imagine a sandy soil doesn't hold on to the water as much. It doesn't have as much pore space, so it doesn't hold as much water, but it also lets water flow through more quickly because there's less adhesion. Or there's less negative matrix potential, right? Okay. Any questions about those concepts? Is somebody?
Can you say you said less negative?
Yeah.
Matrix. Okay. Matrix potential is the force of which water can be drained. So if it's negative.
Matrix potential is the adhesive force of soil on water.
Capillary potential.
So it's like capillarity.
Okay. Yeah. So when you say negative,
It's
less,
always a
that was a
negative.
double negative.
It's always
I
a
just got-
negative number.
Okay.
So the more negative it is, the more strongly it's pulling.
Okay.
So a finer textured soil, all other things equal, a finer textured soil should have a more negative matrix potential than a coarse textured soil. Anything you guys would like to add?
No, but if you guys are confused about these equations or matrix and gravitational potential, Kelsey has really good information in the front of the lab. So just reiterating that for this particular lab, definitely read the lab.
Right. Yeah, and that's the other thing I wanted to say. If, let's say, you're busy. Who's busy? You guys aren't busy. And you didn't get to read the manual, okay? Not all is lost because you can read it after that, right? So do that before you start answering the questions because it's a no-brainer. That's going to increase your score because you'll understand the concepts better, and that's what we're looking for, that you show understanding of the concepts.
And you can narrow to the relevant concepts so that you aren't pulling in so many
Totally.
extraneous things.
Yeah. So, I mean, the ideal circumstance is that you read before and you reread it after, before you write up your things or while you're writing up your questions. Okay. Cool. I also referred to all the lecture notes. You guys should have notes from your time in lecture too. Refer to those and refer to the slides or the study guides. All of that can help to refresh these concepts. Think of it like it is, like I said, it is worth 2 labs is worth a whole exam. So if you think of it in that way,
Labs is a whole exam.
well, they're 50 points each.
But they're only 25% of the grade.
Oh, okay. So they're worth even more. Great. So definitely spend the time on the labs. Treat it like a test. Okay. So we're gonna split up into 6 groups. We're gonna use the infiltrometers. We've got the water here to fill those up. Christine will give you a little rundown of how to do that again. It's the same equipment we used on the very first lab. We're going to split up in 6 groups. We're going to use these transects that we have here, but each group is only going to focus on one transect. So we have right here, starting a transect, we've got 1, 2, 3 different sites. Okay, so each group will have their own transect. So let's say group 1 will start here, group 2 will start there, and so on. Does that make sense? And you're going to measure each one time. It does say in the lab manual, although I could say anything because most of you guys didn't read it, so I could just make up anything I wanted. But it does say that to measure two, measure it twice. We're just going to do it once today, okay? So we're going to measure one infiltration rate. So you need to use the stopwatch on your phone. Most everybody has a phone, or every group should have access to that. And it's the same procedure. We're just going to look at that infiltration rate, and we're going to record the data. So at 3 sites for each group. Is that totally clear?
Yep.
One measurement.
Yeah. Okay.
So if you have moss, for instance, you've got to either find a place that is not covered with moss in your area, or if you can't find a place, remove the moss. But we want to avoid disturbing too much, so only do that if you really can't find a place near your flag. Okay?
Spot space in the lab.
Yep.
Fill the bottom.
Set on to.
I have
I'll do a timer.
Okay, cool.
So almost like read it. Is that flat enough? I think so. Alright, ready to go? Let's tip it over. Yeah, I think it bubbled, so it's starting now. Alright, I'm starting it. I'm gonna call 0.
Starting now. Alright, there we go.
0 is 62.
Every 30 seconds, right?
Yep.
Yeah, nice.
That's Missoula for you. I thought it was every 30 seconds.
Yep.
Okay. Sorry, I thought you said 60%.
Alright, we are at 30.
I freaked out. I jumped up
And go. Go.
I sailed it.
I don't want to read it.
Thank you.
Well, I did the soil preparation, so I think somebody else should read it.
Oh, yeah.
When do you guys want to read this thing?
I can do time.
Oh, man. Right now. 58.
Right.
So that's our first.
Were you reading this wrong?
Because the worst, you can just blame it on, I'm sorry, 56.8.
Okay. That's
You can just blame it on user error.
There you go. We'll just say it's spring and everything is wacky.
Right now. 56. It's like 50. Think about that. Or 60. No, wait. How do I read this? 51. Looks like we're at 51. Alright.
Oh, wait.
Yeah, this dude came in, he's like, is this right? And we checked it out, and we're like, yeah. He's like, I'll buy all of them that you have. So that was it. Like, great. Oh, no, here, let's just, yeah, where we started. Where we started.
Also, I think it's
50, how many?
Yeah, do we just want to get it?
Do I have a trowel? Oh,
I stabbed you with the ink end for a sec.
oh. Good. Sorry, guys.
You don't want to press it too much.
Students
Yeah.
never cause
Right.
fatal plant loss.
More great PR.
Alright, starting now. Alright, what are we at? 52.
Permission from the landowner?
Yeah, I'm not sure what this is.
That was so funny last time.
I know.
That guy.
Over to the gate. the other day, and this dude rolls up in the truck. He's like,
And I
"You
knew
guys
that's
have
what he was
permission
going to
to-
ask.
Yeah,
You guys have
totally.
permission to
Oh,
be
yeah.
here?
Look at
doing
that.
this
Oh,
like right
wow.
as we got back to the gate.
Ooh.
Oh.
Whoa, talk to
Ooh,
Kelsey.
Right now.
51.
Uh, he is, but wait, no, he's not. We're
Not
on
for
to
our
the-
class.
We're on to the new one. Yeah.
It's much better.
Oh, yeah?
51.
all over. They started killing geese until they stopped using them as nests, and so now they got like actually a lot of operators on like. For 360, 49.8.
So 360 is 49.8 and 390 is 49.8.
Okay.
No worries. Not
I'm confused. 390 is 49.
Both 360 and 390.
Cold, so we'll try to keep this as quick as possible. But I want to hear a little bit about what you guys observed. So I'm not going to ask you to do any calculations right now, but you should have a sense, and you can probably also look at your data sheet and figure out in which location did the infiltration level out. You know what I mean, or it stopped changing at a certain point. What does that represent? What happens when
Saturation.
it's saturated? So that time to saturation should be different for these different locations because we would expect the soil moisture to be somewhat different. So what did you guys observe? How long did it take on the south slope?
Longer.
Ours actually took the longest, or it became saturated most quickly on the south slope rather than in the hollow.
Which is
Route where we are.
so over there?
The north
Yeah.
slope.
That's the north facing slope.
Sorry. Yeah.
Okay,
North facing.
and that was so it was quicker there than it was in the hollow.
Saturated.
Yeah, it became saturated. So the
Interesting.
water was very slow.
Interesting.
Our hollow spout was deep in the brambles.
Yeah.
So
Okay.
brambles could
Yeah, but I mean, it's there. The soil is different there, certainly. Right? There's probably more organic matter in the so there could be some differences. What about the south slope, the real south slope, the south-facing slope that is on the north? Yes.
Yeah,
You had the opposite.
we were on the north facing slope and it was really slow, and then we were in the hollow right here and it was super fast.
That was what we had too.
Oh, okay. I heard that.
Okay.
But on the south slope, it took longer to saturate.
It took longer to
Answer
saturate.
to your question.
Yeah, and that is what we would expect. Of course,
Ours saturated.
again, we have to say that it's been raining, right? It rained a little bit today. It didn't rain yesterday. It was nice and sunny yesterday, but it rained all last week. It's the springtime, so we might expect not as big differences as we would see in the fall, for instance, or the summertime. So that said, this was a good experience to measure this in the spring, but just so that everybody has consistent measurements, on Moodle there's an Excel sheet with these same measurements, and you guys are going to use that data to do your write-up. Okay, so not the data you recorded today, but the data that you'll get off of Moodle. So you will think about what you did today, and that will be a useful thing to think about in some of your questions because of what you're observing now, because of the different weather patterns in the spring versus the summer. Does that make sense? Any questions about that? Now's a great time.
The only time. No, not.
It's not the
I
only
have a
time.
question.
Yeah,
With
what?
like the first question, the average infiltration and the range of infiltration, we're using the Excel for that as well, so we're
Yeah.
not using our own data at all.
Yeah, you're not explicitly using your own data. There might be something in there where you'll think about what you observed today.